Hello guys, now question number 64. Question number 64 we'll discuss. Okay. So what actually the question is telling that statement 1 the given cobalt hexamine plus 3 and cobalt hexafluorido plus minus 3. The both are octahedral complexes but the differ in their magnetic behavior. And next statement 2 same compound the given. So the hexamine will be diamagnetic and hexafluorido become paramagnetic. Now we'll see what will happen. The key concept involved here is coordination compounds. Coordination compound. Coordination compound. VBT, valence bond theory. Valence bond theory. So here to decide, see, always keep this few points here. Strong field ligand and weak field ligand. Strong field ligand and weak field ligand. Strong field ligand, what happen? It will be mostly you will having the low spin complex. Low spin complex. Low spin complex means what happen? So mostly diamagnetic species will come. Diamagnetic species. In this case, high spin complex. High spin complex. High spin complex. And you will get the paramagnetic. Paramagnetic nature. Okay. Now that means what happen? In this case, number of unpaired electrons will be zero. Number of unpaired electrons will be zero. In this case, number of unpaired electrons will not equal to zero. Is not equal to zero. So it will have a paramagnetic nature. Okay. Now come to the question. What are the condition they're asking? What we need to do for this question? So focus on this spectrochemical series. So here I will tell how to keep it in mind. How to keep it in mind? First, halides. Halides. Then we have oxygen donor, right? Oxygen containing donor. Then we have nitrogen donor. Then we have carbon donor. This is the order of their ligand strength. This order of their ligand strength. Keep this one order. Easy way to keep it in mind. See here clearly seen that cobalt is a weak field ligand, ammonia is strong field ligand. That means what happened when you write the cobalt VBD, cobalt. So cobalt plus 3 state, right? What will be having in this case? So 4s0, 3d6 we have. 3d6 we have. Now when you try to draw the d orbitals in this case, 1, 2, 3, 4. So we can have the force pairing will be takes place in this case. We have 6 electrons are available. So due to ammonia, in this case of SFL, strong field ligand case, we can do the force pairing, violating the Hund's rule of maximum multiplicity. 1, 2, 3, 4. When you do force pairing, no, so what happen now? We will get the two vacant d orbital. This is 3d, 4s, 4p. So we have the two d orbitals empty and three p orbitals are empty. Right? So we will be having the D2 sp3. This octahedral. See here, number of unpaired electrons are zero. This is low spin complex. Low spin complex means diamagnetic. Diamagnetic. Okay. Now, if we see the weak field ligand, so what will happen? Case of fluorine, right? Same. 3d6 is there. Now, and so here if you try to draw the d orbital, 1, 2, 3, 4. So 1 electron, 2 electron, 3, 4, 5, as well as 6 we have. Okay. Now 4s is empty and 4p is empty. 4s, 4p is empty we have. Now Here, pairing is not takes place due to weak field ligand. Pairing does not takes place. Does not takes place. Pairing does not takes place in this case. Okay. Now that means what happened? We have yes, we have and P3. D what happened? We have to use the 4D. Outer D orbital will be used in this case. Outer D orbital is used. One, two, three, four. So D two orbitals. Right? So here number of unpaired electrons are how many are there? In this case, we have four number of unpaired electrons are there. That means if I want to find out the magnetic moment, you will get n into n plus 2. So 4 into 4 plus 2, that it becomes 6. So that becomes what happened? 4.98 Bohr magneton will come. Right? This one we get it. Now, it is clearly confirming that. So the given statement one is completely fine because both are sp3d2 hybridization. So not sp3. So here, this one sp3d2, outer d orbitals are used. This one d2 sp3. D2 sp3. But both are octahedral, no? Both are octahedral. And differ in their magnetic behavior. Yes. So here this become dia, this become para. Right? Statement one is absolutely right. Statement two, what will happen? So here ammonia strong ligand force pairing takes place. No number of unpaired electrons are available. So it will become so diamagnetic. Cobalt and fluorine weak field ligand we need not to be. We should not do pairing. So dia para will come. Number of unpaired electrons will come as four. So that means what happened? Both statement one and two both are correct. Right? This is the answer for this particular question.